Today we are going to discuss Side 2, Math Paper 7. Okay, now we are going to start question number 1. If 5 to the power p equal to 2 to the power q, what is the value of p by q? Okay, let us discuss the question on the board. Question number first. Okay, so we will find p by q. Here we have to take 1 by qth power at both sides. So it would be p to the power 1 by q, that is equal to 2 to the power q to the power 1 by q. And we know that a to the power m to the power n, that is equal to a to the power m into n. Similarly, 5 to the power p into 1 upon q, that is equal to 2 to the power q into 1 upon q. So q 1 upon q, that is 1, and it would be 5 to the power p by q, that is equal to 2. We have to find p by q, so we can write it as in log form. So p by q can be written as log 2 base 5. Okay, so we shall find value of p by q. This is equal to log 2 base 10 and log 5 base 10. Here we shall take help from calculator. So log 2 divided by log 5, which is equal to 0.43. So this is choice, first question, 0.43. B choice is correct. Second choice. Given set of data 5, 5, 6, 6, 7, 7, 7, comma x, comma y, where x and y represent two different integers. If mod is 6, which of following statement must be true? So mod is the term which comes most number of times in a set of data. Here we can say 5 came twice, 6 twice, 7 came thrice, x and y. So they are saying mod is 6. So mod is 6 means 6 should come more than 3 times, because if it is still coming 3 times, then 6 and 7 both would be the mod. So for mod is 6 means 6 should be either 4 or more than. So x and y. So x and y both should be 6. Okay. So then x mod is 6. Okay. X and y must be 5. If x or y must be 5, then mod is 6. If both are 5, then mod should be 5. If one is 5, one is 6, then still mod is like 5, 6 and 7. So A is not correct, or because mod is 6. Both x and y must be greater than 7. In this case also 6 can't be mod. Third case, if x is 5 or 6, then y must be 6. means one y is must 6 and x is 5 or 6. If x is 5 and y is 6, then mod is not 6. If x is 6 and y is 6, then both are 6. Then it should be mod would be 6. So for this condition, is x y must be any number. No, this is not correct. Okay, C and E, both x and y must be 6. This is the most accurate, even more accurate than C. So E is the last choice where x and y both are 6, then 6 would be the mod. For all numbers x, if a function f of x is defined by f of x when x is not equal to 10, x square when x equal to 10. Then f of 11 minus f of 12. So 11 and 12 both are not equal to 10, so it would be f of x equal to 6. Okay. We shall discuss this question. Question number 2. F of x equal to x, where x is any number other than 10, and f of x equal to x square when x equal to 10. So we have to solve for f of 11 minus f of 12. Okay, 11 and 12 both are not 10 other than 10, so we'll put f of x as x. So here f of x equal to x or x equal to 11 comma 12. So f of 11 equal to 11, and f of 12 equal to 12. So f of 11 minus f of 12, that is equal to 11 minus 12, that is minus 1. So minus 1. Question number 3, its choice is B, minus 1. Question number 4. In order to disprove the hypothesis, no number divisible by 4 is less than 4. It would be necessary to no number divisible by 4 is less than 4. So that some number smaller than 4 are not divisible by 4. Demonstrate that numbers greater than 4 are often divisible by 4. No, this is not correct. indicate that many numbers greater than 4 are divisible by 4. This is also not correct because question they are saying no number divisible by 4 is less than 4. So we have no need to even think about greater than 4. Prove the statement false for all numbers divisible by 4. No, this is also not correct. Provide one case in which a number divisible 4 is less than 4. So in this case, A and E show that some numbers smaller than 4 are not divisible by 4 and provide some case in which number divisible by 4 is less than 4. So E is correct. If we will have even one number that is less than 4 and divisible by 4, then the condition which is given disapproved this hypothesis. So E is the correct choice. Because for disapproving we will check only one number 2 which is less than 4, and on the basis of that we can disapprove this hypothesis that no number divisible 4 is less than 4. Polar coordinate of a point P (2, 45). How many units above the x-axis is the point P? So in polar coordinates, how many units above the x-axis point P? So let's discuss this question. So this point, suppose this point is P. So how much distance it is above the x-axis? It is P sine theta. Sorry, 2 sine theta. P point, this point from the x-axis is, you can say PQ. So this PQ is 2 sine 45. Okay. So its option is B, 5B. So we can also do it like this way. Otherwise, we'll convert this polar form into rectangular form. X equal to r cos theta, y equal to r sin theta. So find y. P is the coordinates are x comma y. So let us discuss by this method too. So x equal to r cos theta means 2 cos 45. So this is equal to 2. Sin 45 is 1 over root 2. That is root 2. So this distance is y and this is x. Whose coordinates are x comma y. So this is again root y equal to root 2. So again the same answer, that is root 2.